So then this part, you have to describe the reactivity series based on how willing the metal will form positive ion. So that means, will it form this? Will it become an ion? So if this process happen readily, quickly, then this is considered a reactive metal. Then if it doesn't, right, if it doesn't happen, then it's supposed to be a less reactive metal. So this section is talking about aqueous ions, which means we are talking about displacement reaction. If you go back to periodic table, you will see this. In periodic table, we done group one tell you that more reactive metal will displace less reactive metal from its salt. Still can remember that or not? Yeah. So the reason is because the more reactive metal will tend to form ion. So the less reactive metal will not. Lesser chance of less reactive metal to form ion. So what will happen during displacement is like this. Let's do some drawing. Okay, I have a solution. Please choose a pair of metals. Choose one less reactive, one more reactive metal for me. Give me name. Okay, sodium. Not ignoring all the safety concerns. Now we have sodium and another metal, another less reactive metal. Okay, so it's like this. So if so I have a solution, then say I put sodium metal here. So then let's put copper sulfate solution here. No, silver sulfate. Let's put silver sulfate. Okay, so that means here there will be silver ion, sulfate ion. So sodium is more reactive than sodium metal. So what happened is sodium will ionize. It will lose electrons and then become ions. So the sodium ions will enter the solution. You get this portion? So you have electrons donated by these two sodium. So that is whatever the first point is saying. Can? First point, okay? So then there's the ions of less reactive metals. In this case is sodium. No, silver. So it's silver. So silver will take the electron that sodium donated, and then it becomes sodium atom. Silver atom again. So it becomes silver. So this is what we say it will gain electrons and are discharged as atoms. This is the process. So in the end, you will see silver metal here at the bottom. Because sodium is it's a very reactive metal, this process will be very fast. Then if you were to replace this with another setup with copper, then this reaction may become much slower because there is a lesser tendency for copper to ionize and become an ion. So these two will still work, copper, silver, gold. So if you have another reaction now, then you have silver solution. Then I put in a piece of gold. Gold is lower than silver in the reactivity series. So then it will not ionize. So if it doesn't ionize, right, then this displacement reaction will not work out. Okay? Then are we still alive? Are we still together? Okay, so that will happen. So in a displacement reaction, you will have two things that you need to observe. And exam questions, test questions, love to ask for these two things. They love to ask for observations. So observations will mean that you may see a metal deposit in the solution, or you will see the solution changes color. So these two are very likely to happen. So we have one example. You have a zinc metal strip and then it's dipped into copper sulfate. So let's not do state and explain the observation, but tell me what reaction will there be between copper sulfate and zinc? Displacement reaction. Who displaces who?
Displaces copper.
So it becomes zinc sulfate and copper. Am I right to say so?
Yeah.
So So now, because they say state the observation and explain the observation, we know this reaction happens. Are you familiar with the colors for zinc and the colors for copper sulfate?
No.
No, huh? So that means later on I will add a table and give you the table regarding colors. So copper sulfate, right, is a blue solution. Zinc is a gray metal. So now this is gray. The gray metal dip into a blue solution. Okay, let me tell you, this is a colorless solution. And copper is a reddish brown or pink metal. So if you dip these two together, what happens is the gray metal will dissolve. So it dissolves and the blue solution will become colorless. Then you have deposit here or here. Then you see red brown deposit on. So you see red brown deposit on the zinc. So the state will be the gray metal dissolves and a pink or red brown deposit is seen on the zinc metal or deposit at the bottom of the thing of the flask or the beaker. Then the blue solution turns colorless. Just for observation, that means you write whatever you can see. State the observation means you write whatever changes you can see. Then they ask for explain the observation. Then you say that the zinc, the gray metal and the zinc, because it is higher in the reactivity series than copper, it will ionize, it will dissolve into the solution and produce zinc ions. Then why you have a deposit? Because zinc displaces copper metal from copper sulfate because of the reactivity. Then the solution, zinc sulfate solution is formed, then copper sulfate solution is used up. So the blue solution become colorless, something like that. So that is the description that you need if they ask for an explanation like that. They give you a question like this, then you have to do that. Can? So you have to say zinc displaces copper. So copper is formed is red brown. Then why it displaces is because zinc is more reactive. Then the solution change from blue to colorless because copper sulfate is used up and zinc sulfate, which is colorless, is formed. Your answer would require these few points if this is the explain part. If you want explanation, this is the explain part. Let's try another one. We have iron and magnesium sulfate. Iron is let's give you this. Iron is a gray metal as well. Magnesium sulfate is a colorless solution. Then iron will displace magnesium or not?
No.
Nope. Okay. So okay. And anyway, iron 2 sulfate is green. So now you state and explain the observation. Practice writing. So okay, they say state the observation, part 1. So state the observation means no visible change or no reaction. So part 2, then you say no reaction because magnesium is higher than iron in the reactivity series. Okay, wait, sorry, here. Explain, then state. State means you write whatever you see, so you cannot see anything, so there's no visible change. Okay, this is correct. Okay.
Yeah.
So you have 4 test tubes. Then in the 4 test tubes, there are 4 different metals and they are placed into different solutions. So then you are supposed to name the reaction if there is that takes place in all 4, or which one has reaction and which one does not have reaction. So what are we trying to test on here? What kind of reaction?
Displacement.
Okay, so displacement reaction. Name the type of reaction. So displacement reaction. So number 2, okay, how does this type of reaction relate to the reactivity of the metal? So first of all, I would like you to highlight which setup will have a displacement reaction. 1, 2, 3, 4. Which one has displacement reaction?
What?
Okay, so displacement reaction. Okay, so which ones have displacement reaction? You say 1.
Yeah.
Okay, displacement happen when it's more reactive, displace less reactive.
Since the reactant is supposed to be the more reactive one.
So no, the metal, if it's more reactive, will displace the one from the liquid. So copper and zinc nitrate.
And number 2.
So this one does not, no reaction will happen because copper is less reactive than zinc. So this one out.
And number 2.
Yes, number 2, zinc is more reactive than lead, so displacement happen. Number 3,
Number 2, 3, and 4.
3, any displacement?
2 and
4
4.
that 4 there's reaction because magnesium is more reactive than iron. 3, right? Sodium is more reactive than calcium. So how does this, what does this type of reaction relate to the reactivity of the metal? So is this. So the answer is this. The more reactive metal displaces the less reactive metal from its salt. So this is no reaction. Then this is reaction, cross reaction. You answered just now. I asked for your answer just now. Okay, next. Write the chemical equation if the reaction has taken place in any of the test tube. Pick one and then write the chemical reaction. So the ones that you can choose to write chemical equation will be this one and this one. So you pick one of them and write down the equation. Where did the Na come from?
Sodium.
Zinc plus sodium nitrate. The zinc equation, the zinc one,
is copper nitrate. Lead nitrate.
lead nitrate. So then equation wrong. What? Lead. What? Do you want to change your answer?
Yeah.
So okay, so we help you a bit. So we start with this. So it's zinc plus lead 2 nitrate. Then you told me it becomes zinc nitrate and lead metal. Okay, so you write down the symbol for each of these below. Okay, so lead nitrate is correct, the formula. Then zinc nitrate, zinc nitrate. You want to double check zinc nitrate? Is there a problem with zinc nitrate? Is there something wrong with zinc nitrate? Correct. So this one okay already. So then you don't need this, huh? You're correct. Then zinc correct, then lead. Correct. Yep, okay.